A red and blue waterfall scrolling down a boxy beige monitor in a dark bedroom, 1999. It is a screensaver. Millions of people installed it. It was searching for aliens, and over the next 21 years, it never found a single one. But the pretty picture was a disguise. While a home computer drew that waterfall, it was doing real radio astronomy. And added to a few million others, a few million screensavers all lit up at once in the dark. Together they briefly became one of the largest computations anyone had ever run. It was called SETI at home, SETI for the search for extraterrestrial intelligence. So how does a screensaver become the biggest computer on Earth? And how many aliens did it find? For decades, the idea had been obvious and impossible. Get thousands of ordinary computers to split one enormous job. What changed in the late 1990s was the home computer. It had just become two things at once, connected to the internet and fast enough to do science in its spare time. This came out of Berkeley, the Berkeley SETI Research Center, not the more famous SETI Institute across the bay. A software engineer named David Gedde had dreamed it up, with the astronomer Woody Sullivan, the radio astronomer Dan Wertheimer, and the distributed computing scientist David Anderson, four people betting that the world's idle computers could be talked into doing science. It needed money, and no sponsor stepped forward until the Planetary Society put up the first $100,000. That money came from two places: the Carl Sagan Fund for the Future, and a donation from Paramount Pictures, timed to the release of Star Trek Insurrection. The search for real aliens, paid for in part by fictional ones. It went public on the 17th of May 1999. About 200,000 people downloaded the program in the first 48 hours, and they kept coming. Eric Corpella, one of the scientists, remembered it this way: "We thought we might get 10,000. The day we turned it on, we had close to 500,000 show up." The servers crashed repeatedly. It had been built to handle maybe 50 to 100,000 computers. By that August, it had 1 million users across more than 200 countries. 2 million by its first birthday. 3 million by its second. Over its whole life, more than 5 million people ran it, never all at once, but one after another, for 2 decades. That scrolling waterfall was never decoration. It was the literal output of the radio math. The computer was doing the same picture the astronomers wanted, drawn live as the machine made it. The eye candy and the experiment were the same object. So what was the math? The search listened through the giant Arecibo dish in Puerto Rico, though it never aimed it. It took whatever slice of sky happened to drift overhead, riding piggyback on Wertheimer's receiver, and Arecibo had no fast internet line, so the raw recordings were written onto tapes, then hard drives, and physically put in the mail to Berkeley, a planet-spanning internet computer whose front end ran on the postal service. Berkeley chopped the radio stream into bite-sized pieces, 107 seconds of a narrow band, about 350 kilobytes each, small enough to crawl down a dial-up line in a few minutes. Each home computer, when running the screensaver, grabbed one piece, hung up the phone, chewed on it for hours, sent back a tiny summary, and asked for the next. No two of the 5 million computers ever spoke to each other. To catch a faint alien tone when nobody knows its pitch, each computer scanned its piece across thousands of possible pitches at once, 15 zoom levels, from a slow whisper to a near shriek. And a transmitter on a spinning planet slides in pitch as the planet turns, so each piece was rechecked against about 123,000 different slides. 15 zoom levels times 123,000 slides is nearly 2 million passes for every single 107-second piece. That is the arithmetic that needed a planet of computers. A home computer can be broken, pushed too hard, or simply lying, so every piece was handed to several strangers' machines and the answers compared. Only agreement counted. Across the whole project, the screensavers flagged about 12 billion promising little blips, 12 billion maybes to sort through. Added together, those idle screensavers did something no single machine could. For stretches around the year 2000, the pile of volunteers crunched numbers faster than the fastest supercomputer then running. Purpose-built machines would later pull far ahead, but for a while, this was the front-runner. Its own creators, writing it up, called it the largest computation ever run, and Guinness World Records lists it to this day as the largest distributed computing project. Not one computer, every idle PC on the planet, added up. People got competitive about it. Strangers formed teams, chased leaderboards, and raced to crunch the most pieces. Somewhere along the way, citizen science had quietly turned into a game. It had exactly one famous moment of hope. In 2004, the press announced the most promising signal yet, a blip the volunteers had flagged, with the unlovely name SHGB02+14A. The scientists spent the following week explaining that it almost certainly wasn't aliens. Its pitch slid so fast it would mean a planet spinning 40 times faster than Earth. It was never seen again. The excitement was the reporters. The correction was the scientists. On the 31st of March 2020, after nearly 21 years, SETI at home stopped handing out new work. Not defeat, a planned pause the team called hibernation, so they could finally sit down and read what 5 million computers had turned up. Anderson's framing was almost boringly reasonable. This is a normal experiment. Gather the data, then write up the conclusions. It took 2 more papers, in the Astronomical Journal in 2025, to finish reading the data. Across roughly 14 years of Arecibo recordings and nearly the whole visible sky, 12 billion flagged blips came down to a few hundred candidates and not one confirmed signal from anybody. Anderson's verdict: it's unlikely there's a signal buried in there, but we now know how quiet the sky is, and that is worth knowing. A 2026 follow-up is still rechecking about 100 of the leftovers. The search is afterlife, not a discovery. The real discovery was never up in the sky. It was the machine itself. SETI at home didn't invent this trick. GIMPs and distributed.net had got there first. In 1996 and 97, one hunting for record-breaking prime numbers, the other cracking encryption challenges to prove it could be done. But it proved the idea at the scale of a whole planet. And in 2002, Berkeley turned it into reusable plumbing, called BOINC, so anyone could now borrow the world's idle computers for any big problem at all. On that same plumbing, new screensavers went hunting other things. Einstein at home searched for gravitational waves and never found one, though its volunteers did turn up new pulsars, spinning dead stars nobody had noticed. Rosetta at home worked out the shapes of proteins, and the scientist behind that protein project, David Baker, went on to win half of the 2024 Nobel Prize in Chemistry for computational protein design. Baker's lab even turned the problem into a video game called Fold It, and in 2011 its players worked out the shape of an enzyme from a monkey virus that causes an AIDS-like disease, a structure that had defeated scientists for over a decade, in about 3 weeks. They were listed as co-authors on the paper. A sibling of the whole idea, a separate program called Folding at Home, not a descendant of it, put the same trick to work on disease, and during the 2020 pandemic grew into one of the largest computing efforts anyone had ever assembled. An alien-hunting screensaver spent 21 years and 5 million computers and never heard a whisper from anyone out there. But it taught the world a trick worth more than the aliens would have been. A few million idle machines, sitting in the dark doing nothing, are one of the most powerful computers on the planet. And that trick never needed aliens to be worth it.